Hello everyone, this is your junior high school math teacher and we are now in our second week lesson in your add-on mathematics. And this is about solving an oblique triangles. So after you watch the video, you should be able to solve oblique triangles and solve problems related to such triangles. In this video or material, you shall be able to apply the principles of solving oblique triangles in trigonometry in order to solve related word problems such as angular directions, like courses and bearings. Now let us begin with oblique triangle or oblique triangles. What are these triangles? From the definition, an oblique triangle is a triangle that does not contain a right angle. An oblique triangle is labeled the same as a right triangle. That is, in oblique triangle ABC, the angles are labeled alpha, beta, and gamma, and the lengths of the opposite sides are A, B, and C, which are the opposite of alpha, beta, and gamma respectively. Now, suppose we have this drawing, an oblique triangle, and this is named as triangle ABC. Since we use the first three capital letters in the English alphabet A, B, and C. And for the angle at vertex A, it is denoted as alpha. And for the angle at point B or vertex B, it's beta. And for the angular measure at C, it is denoted as gamma. And for the side opposites angle alpha, that is small letter A or side small letter A, and we have for the side opposites angle beta, it's small letter B, and for the longest side opposites the angle at C, which is angle gamma, is side small letter C. Okay. Now just like in solving right triangles, we could also solve an oblique triangle. And how are we going to do that? Okay. There are four possible cases of problems involving the solution of oblique triangles. And they are as follows. For case number one, we solve an oblique triangle if the given parts are these combinations, one side and two angles given. Okay? Now suppose, again, we refer to the same oblique triangle, and from this drawing, the three given parts under case number one are these. This side, which is the opposite of this angle A or alpha, together with the opposite angle alpha and angle beta. Okay? So meaning, to solve this oblique triangle, we need to determine the measures of the remaining parts. And what are these parts? It could be angle C together with this side and this side. Okay? For our second case, the given parts from this oblique triangle are the following. Two sides and an angle opposite one of the sides given. One of the two given sides, probably this one, together with the opposite angle. And the third given parts is this side. Okay? So these are the three given parts from this oblique triangle under case number 2. For our third case, the combination of three given parts are what? Two sides and an included angle. So probably one of the two given sides is this one, and the other given sides is this one, and the third given parts is the angle between the two given sides, which is denoted by gamma. Okay, so we call this an included angle because it is found between the given two sides. Okay, so that is the third case. And for the fourth case, the combination of three given parts from this oblique triangle are simply the three sides. So the unknown parts there are all interior angles. Okay, next slide. Okay, so these are the labeled three sides, meaning that these three sides are the given measures. So the unknown are the three angles. Next slide. In solving oblique triangles, we make use of the sine law or and cosine law. Okay. Now, when do we use the sine law and when do we use the cosine law? Now, for this video, let us focus our attention on law of sines or the sine law. And we will be dealing with the second formula in our second video presentation or next video presentation. Now, for the law of sines, let us consider an oblique triangle ABC on the figure on the right. Okay, so this. Now, although we have two drawings here, but these two refers to the same figure, no? Okay. And that is triangle ABC. Now what you see from this representation for this slide is actually the derivation of the law of sines. So I'll just present this without explaining in detail the step-by-step method of deriving the formula. Okay. Again, what I'm presenting you right now is the derivation of the formula for the law of sines. Okay. Now, the equation that is highlighted by color blue is the one I'm referring to as the law of sines. Okay. Side small letter a over sine of angle A is equal to side small letter b over sine of angle B equals side small letter c over sine of angle C. Or we could rewrite the formula wherein we interchange the position of the numerator and the denominator. So basically, the two formulas are the same. Okay? Now, this is the law of sines. Meaning, so if we are going to interpret the formula, it means that in a triangle or in an oblique triangle, the ratio of one side to the sine of its opposite angle is constant. Okay? Now when do we use this formula or this sine law? Now, the sine law is used in solving the first two cases of problems involving oblique triangles. Okay, so as you can see, I have just presented the four cases, and among those four cases, case 1 and 2 uses this formula, the law of sines. It means that the remaining last two cases we use the law of cosines. Okay, so again, law of sines is used in solving the first two cases of problems involving oblique triangles. Now, case 1, again, we go back to case 1. One side and two angles are given. Okay, so let us apply the formula. the law of sines. Suppose we have triangle ABC. Alpha has a measure of 23 degrees while beta is 68 degrees and side small letter a is 12. So we're going to solve for the remaining three parts from this triangle, and these are angle gamma together with side small letter b and side small letter c. Now for our solution, the sum of the measures of the interior angles in a triangle is 180. Since two of those three angles are given, we could easily find the measure of the third angle by simply subtracting the sum of the two given angles from 180 degrees in order to obtain the measure of angle gamma. Okay? Or we could sum up the measures of all interior angles and equate it to 180 degrees. And from here, we plug in the values of alpha and beta and then solve the resulting equation for the unknown angle gamma. And from this solution, angle gamma is 89 degrees. Okay? Now, to solve for side small letter b, we use the law of sines. This one. And we simply take away one of the three ratios here. Okay? Or not necessarily, no? So, let's just simply substitute the given measures to this formula. So, side small letter a is 12, sine alpha is 23, which is equal to b over sine of 68 degrees is equal to c over sine of 89 degrees. So, from this extended proportion, we take two ratios at a time. So here we're going to consider these two ratios and we solve for b. So by transforming this proportion, the equation becomes b is equal to 12 sine of 68 degrees over sine of 23 degrees. And using your scientific calculator, okay, okay, so separately we do the same thing with c. So this ratio is equated to this ratio. And at this point, we formed another proportion, which is solving for c. And transforming that resulting proportion, we have c is equal to 12 sine of 89 degrees over sine of 23 degrees. Now, using scientific calculator, we solve for b and c from these two equations. And here, we obtain for the value of b, which is approximately 28 or 28.48. And for side small letter c, the result is equal to 30.71, or that is approximately 31. Okay? Next. About case 2. Two sides and an angle are given. Now, these are the given measures, meaning the unknown parts here are angle C, side AB, and angle beta, or angle B. Okay? Now, this case is often referred to as an ambiguous case because it is possible that the triangle being described does not exist, or there may be one triangle or two triangles satisfying the given condition. Now, suppose side small letters A, B, and angle alpha are given, then solving for beta, we have the following. Now, if it happens that sine beta is greater than 1, we know that when we talk about sine values, such value is not greater than 1. So it means if we obtain a sine value which is greater than 1, therefore, that particular angle does not exist, and it also implies that there is no existing triangle, or there is no triangle formed. Okay? Now, if suppose we obtain the value of sine B which is equal to 1, it means, or sine beta is equal to 1, it means that beta has a measure of 90 degrees. It means the triangle exists here is right triangle. Now, if sine beta is less than 1, two angles are determined, an acute and an obtuse angle. Therefore, there may be one or two triangles formed. Okay. Now, the number of possible triangles formed by two sides and an angle is summarized below. Okay? We refer to the same oblique triangle with the same set of given parts. Now, we project an altitude or the height drawn from point C to the base. Okay. Now, this height right here is actually equivalent to B sine of alpha. Okay. Which means B is your hypotenuse in reference to this right triangle. Okay. Now there are three subcases involved. If alpha is an acute angle and side small letter A is shorter than this side small letter B, there are three possibilities. And what are these possibilities? Two triangles are formed if A is greater than this height, which is equal to B sine of alpha. Or one triangle is formed if this A have the same length as this height. Okay? Yun ang ibig sabihin nun. And third possibility, no triangle is formed if A is shorter than the height. It means if this is the height, this side right here is shorter than this one. Meaning, this side right here cannot reach point B. So it means there is no triangle formed. Okay? Now, these three possibilities are under case number 1, wherein alpha is an acute angle and side small letter A is shorter than side small letter B. Okay? Next. Case 2. Now, if alpha is an acute angle and A, side small letter A is longer or this having the same length as side B. Okay, then there is only one solution, or there is only one triangle that exists. Next, if alpha is an obtuse angle or right angle, then there are two possibilities. One triangle is formed if this side right here is longer than this side. Or should I say, this side right here is longer than this height. Okay? Or second possibility under case 3, no triangle is formed if this side is as long as this one or shorter, or this side is shorter than this one. Okay? Okay, so if there is no question at this moment, let us proceed to the next slide. Let us have some example. Determine the number of triangle possible with the given parts. Now, the three given parts from the oblique triangle are the following. Alpha is 32 degrees, side small letter A, which is the opposite of this angle, is 5.1, and the other side is 10. Next, for the second item, the given parts have the following measures. Alpha is 50 degrees, and side small letter A is 23, while B is 19. The third item, angle alpha is an obtuse, which is 126 degrees, together with side small letter A, which has a length of 20, and side small letter B having a length of 25. So for our solution, let us consider this given part. So what shall we do? Now, alpha is an acute angle and side small letter A is shorter than side small letter B. So we use case 1. And what is that case 1? Okay. So if we're going to compare this side to the height of the triangle, which is expressed as B sine of alpha, so 5.1 compared to 10 sine of 32 is what? Okay, so 5.1 is shorter than 5.29, which is this one. So what does this imply? It means there is no triangle formed. Okay? Now, number 2. What about the three given parts? Alpha is 50 degrees, side small letter is 23, and B is 19. Now, since alpha is an acute angle and A is as long as B, or longer, A is longer than B, then there is exactly one triangle formed. Okay? So indeed, A is longer than this one. So it means there is only one triangle that is formed or exists. And then for the third one, alpha is an obtuse having a measure of 126 degrees, and side small letter A is 23 and B is 25. Since alpha is obtuse and side small letter A is shorter than B, then no triangle is formed. Okay? Now, another example, in adjoining figure, find the measure of angle CAD, this one. Having the question mark, we don't know the measure of this opening or this angle, that is angle CAD. Now, if AD is 160, this one is 160 meters, BD is 75, and triangle BAD is 15. So this angle right here is 15. So we are asked to find this measure. So what do we do? Solution. Okay. So we make use of the law of sines. 75 meters divided by sine of 15 degrees is equal to what? 160 degrees over sine of B. Okay. So in this proportion or law of sines, we can solve for angle B by transforming this equation, solving for sine of B, and this is the transformed equation. And from here, from that equation, we simplify this part using the scientific calculator. So 60 times sine of 15 degrees over 75 is actually 0.5521. And from this equation, angle B is equal to the arc sine of this value. Now, using your scientific calculator, angle B is approximately 34 degrees. So this angle right here is 34. Okay? And we know that the sum of the measures of the interior angles of a triangle is 180. Therefore, triangle DAB and triangle BDA and triangle and uh, angle DAB rather plus angle BDA plus angle B is equal to 180. So substitute. Angle DAB is 15, angle B is 34. So angle BDA is what? 131. Now, we know that this angle is 131, therefore we could easily get this angle by getting the supplement of this angle. And angle CAD is 41 degrees. Okay, so it means angle ADC is 49, which is the supplement of 131. Okay, and this is the answer. Of course, angle ADC is 49. Okay,